Alright, and in this lesson, we're actually going to look at the last two methods of separation techniques, which is your distillation as well as paper chromatography. Okay, so likewise, we always go into the fundamentals of what exactly allows us to decide to use this method or not. Okay, so for instance, what you learned in the previous concept was that, for instance, for filtration, right? Filtration is only used when you're trying to separate an insoluble solid from a suspension. So this is the fundamental concept that we will explore. So likewise for distillation and paper chromatography, we're going to take a look at what exactly I'm looking out for. Okay, so this is exactly how distillation setup looks like. You might have seen this in the lab. If not, don't worry. So basically in the distillation setup, just to let you know, it's actually a method to use to separate the pure liquid, which is the solvent, out from the solution. The liquid that we obtain is what we call the distillate. Okay, so it's a term that we use to describe the chemical that comes out when we actually perform distillation. And this entire distillation actually uses both boiling and evaporation, followed by condensation for the reaction to happen. So, how does it look like? For instance, if you look at this entire setup, basically in this flask over here, this reaction container, right, is where I have my mixture. So what I do is I actually supply heat to the mixture so that I can help to remove the solvent, because the solvent will be able to evaporate or boil, and it will exit out as a gaseous form or as gas, okay, or as water vapor in this case. So when the gas moves up, eventually you will pass through this channel over here. So when you pass through this channel, you interact with this part that's called the condenser. Now the condenser has tap water going in, which is considered a colder temperature as compared to the gas because we heat it up originally. So this colder tap water, right, will make this entire condenser a very cold environment, and that's why inside here, what will happen is that condensation will take place. Okay, so with condensation happening, eventually the liquid, right, will form and will drip out from this remaining part. That's why we call this a distillate, what we collect over here. So this is actually a method for us to retrieve back the solvent out from the entire solution. So some of the things to take note, you'll notice in this entire setup there's this thing called the porcelain chips. Okay, sometimes we also call it the boiling chips. Okay, the purpose is to make sure that boiling actually happens very, very smoothly so that it doesn't become too dangerous, so that the thing won't splash and overspill into the condenser. Okay, to take note that the seawater in the flask is heated until it boils. So once it boils, right, the water vapor that rises up eventually will pass through this condenser. The water vapor will cool down and get condensed into forming pure water, which is what I call the distillate.
When performing a distillation, first the condenser is filled with cold running water. Next, heat is applied to the mixture, which is to be distilled. The mixture is heated until it boils, and the hot vapors will travel up the distillation head. Measuring the temperature of the vapors helps us to identify the liquid being distilled, and will help to confirm its purity. If the vapors are pure, they will have a constant temperature equal to the boiling point of the liquid being distilled. As the vapors travel into the condenser, they will be cooled and will liquefy. The liquid droplets, called the distillate, run down the condenser and are collected in a receiving flask.
So in this video, this is what we're trying to show you how distillation setup actually looks like and how it can be used to collect solvent out from a solution. What are some examples of distillation in our daily life? Now, in the lab, we actually use this to separate water from salt solution. That's number one. We can also use this in our daily life to actually obtain what I call distilled water. We can use distillation to obtain to make perfumes, because to collect the extracts from the different herbs or different flowers. We can also use distillation to obtain alcoholic drinks, because after you make the alcoholic drinks, right, you must be able to retrieve back the alcohol from the original chemicals that were inside. So you use distillation to do that. Take some time to think about some of these questions over here. Okay, so in your notes itself, you realize that there's a lot of questions asking you what exactly is the purpose of this, why must this thing be placed like that, so on and so forth. So I would really like to challenge you to think of some of the reasons why this apparatus are actually placed at that position. Okay, take note of your answers. Just write it out on the paper. You can write it out in pencil if you want, if you're not sure, and actually submit this work back to your teachers so that we can give you feedback when we meet next time. Alright, so these questions, I want you to think about it by yourself. Now, there's another kind of distillation, and that's what I call fractional distillation. Now, you learned in math before about fractions. Now, fraction refers to many small parts, right? So what exactly is fractional distillation? Basically, fractional distillation is a method that we use to obtain a liquid, which is similar to what you previously learned, but this time around we use that to obtain a liquid from a mixture of two or more liquids. Now, do take note that initially the one they learned previously is what I call simple distillation. In simple distillation, what you do is you actually obtain a liquid from a mixture of liquid and soluble solid. That's all you have. So inside the entire mixture, there's only two things, either the solid or the mixture. So there's no need for you to have so many liquids inside. But this time around, if you have a mixture that has many liquids inside, for example, petroleum, the one that actually draws out from the bottom of the sea, those are petroleum that draw out, right? It's actually a mixture that contains a lot of liquid. So what this means is that if you want to separate each of the liquid, right, it'll be very tricky, and the only method to do that is to use fractional distillation. This is how the setup of a fractional distillation look like. You realize that it still has the condenser, still has water entering in and water leaving. It has a thermometer. So everything seems pretty much the same, just that there's somehow this entire section here that's added in. This is what I call the fractionating column. Now the fractionating column is a very impressive apparatus. What it can do is that it actually allows different liquids separated individually, which means that you just need a fractionating column and you can separate out different liquids one at a time. So what exactly is the difference over here? Okay, we're gonna move on a bit further than Sec 1 syllabus, just to let you know what's going on. Basically, the liquid will actually be separated out based on their boiling point. Okay, so the liquids are separated based on their boiling point, which means to say that some of the liquids will have a lower boiling point, some of them will have a higher boiling point. Can you make a guess which kind of liquids will be collected first? Those that boils at a lower temperature or those that boils at a higher temperature? The answer is that those that boils at a low temperature will actually be collected first. Why? Because we are heating up over here, right? Those that boils at a lower temperature will actually boil first, and once it boils first, the vapor will actually rise up and eventually will pass through the condenser first, and it will be collected first as the first type of distillate. Alright, so the next liquid that has another boiling point that's slightly higher will boil next, then the same process repeat. So basically, liquids of a lower boiling point are collected first. Okay, so the one with the highest one will be left behind. So in this particular order. So inside this mixture, if there's say like 5 liquids, and all 5 liquids have different boiling points, the one with the lower one will start to be collected first because it gets heated up faster and it boils faster. Now, same thing over here. I want you to challenge yourself because you have learned about evaporation and now you're learning about distillation. Now, both evaporation and distillations are used with seawater. Now, seawater is a mixture, in fact, it's a solution that consists of salt and water. Okay, so it's a seawater that's salt and water, and you can in fact use distillation or evaporation with seawater itself. But do you know what each of the methods will give you? So, for instance, if you use distillation on seawater, what will you actually collect? What is the one thing that you actually retrieve at the back? If you use evaporation with seawater, what is the thing that you'll be collecting at the end? So can you fill this out by yourself? And likewise, you'll be submitting this to your teachers as well. Next, what exactly is the main difference between the method that I showed you earlier on at the start of the video about simple distillation and the one that you just learned over here about fractional distillation? Likewise, make your comparison over here and share the answers with your teachers. Now, we have been talking about this since the very start of the lesson, which is about the mystery case of the death of Thomas the Minion. Now, if you recall, at the scene of the crime, the murderer actually left behind a block of ink. Alright, and there's 4 suspects. Okay, if you still recall who they are. Okay, so out of the ink, okay, it's actually made out of a mixture of substances that are dissolved in a solid. Now, the question to you right now is that, is it possible for us to use simple distillation? You know, I'm saying simple distillation, for you to separate all these different substances that are inside the ink. Okay, we are using simple distillation in this process. Okay, if your answer is yes or no, please explain your answer. Okay, and likewise, this will be a component where you submit your work to the teacher itself. Last method that we are left with is paper chromatography. Now, paper chromatography is an interesting experiment. If you have the chance, we'll be doing this in school. Okay, because it actually allows you to separate certain chemicals that you might not have think would have existed before. Now, paper chromatography is usually used to separate colored substances in a mixture, such as the dye, for instance. Alright, so we use paper chromatography to do that. What exactly does it look like? Basically, in this technique, right, what we do is we actually get the dye that we want to separate. So, for instance, in this entire setup, right, this purple dot over here that I'm shading now, it's actually the dye. So, you're just gonna put one spot of it on the paper itself. That paper is actually the filter paper, right? And you just put a drop of the dye solution at the near towards the end of the filter paper. Okay, place the filter paper within a solvent, but make sure the solvent doesn't touch the ink. Make sure the solvent doesn't touch the ink. Why? Because we don't want the solvent, okay, to actually dissolve the ink. Then the entire ink will just smudge, and you don't get any separation. So what this technique does is that it actually allows for the solvent to be slowly soaked up, and it will move up the entire filter paper. Right, that's the idea of this technique. So you let the solvent slowly be drawn upwards in the filter paper. Very much like if you take a paper and touch on water, right? The same thing will happen lah. So the paper will slowly get wet because the water will be moving upwards. So in this case, with the help of the filter paper, the solvent will actually be moving upwards. And the amazing thing that happens is that the solvent will actually interact with this dye over here. It will dissolve the dye and separate out into the different chemicals that's inside. So we're going to take a look at a video of how paper chromatography should look like if we were to carry out an experiment.
This video shows an example of a chromatography experiment. The goal of the experiment is to separate the different pigments of ink which are present in a wet erase marker, which we'll see right here. So a vis-a-vis marker is wet erase, which means that the pigments are water soluble. We'll start our experiment by drawing a line with the marker on the chromatography paper. Then what we want to do is insert that chromatography paper into a beaker with a small volume of water in it. We can see that the water will start to rise up the chromatography paper because of capillary action. You'll note this happening very quickly because this is 16 times speed playback. We can see that the ink, which originally looked black, is starting to separate into different colors. This is because the different pigments have different properties. Some of them are heavier, some are lighter, some are more soluble in water, some are less. Because of these differing properties, all of the different colors are going to travel at different speeds.
As you can see in the video itself, right, substances can be separated from just an ink spot or dye in this method that we call paper chromatography. And the end result is that you should end up with a lot of little different colors that's actually found within that tiny spot itself. So how exactly does this technique work? Basically, in paper chromatography, you realize that the spots are separated at different locations because the substances actually move at different rates. So some of them move slower, some of them move faster. So what is the difference? Basically, whichever spots that move faster are the more soluble spots, which are those that have the more soluble substances. Those that didn't really move much are those with the least soluble substances. Okay, and through this method, we can just separate the ink spot to see out what exactly is inside the original spot. So why are we able to tell whether the substance is soluble or not? Remember at the start I said that there's solvent here? So the solvent is going to slowly move upwards, right? When you move up, it's going to dissolve the original spot, and if the spot contains substances that are very soluble, it will continue to be dissolved all the way up until it reaches the top part. So those at the top part that move further, faster, will be those that have the more soluble substances. Now the spots that move only a bit, like say over here, okay, are actually containing substances that are not very soluble, so that the solvent can't really move the entire substances upwards. See? So this is how we can actually differentiate whether the substances is soluble or not. Now what are some of the purpose of paper chromatography? Number one, we actually use it to separate the colored substances in the dye when we're in the lab. Number 2, likewise, we can use this to identify the colors that are found inside a particular dye. We can also use it to identify colored substances which are used in food products such as sweets or canned vegetables. We can also use it at the end to detect pollutants in water. Now, this technique is a bit more interesting, so I would suggest that you read up a bit online or read your textbook to find out how paper chromatography can actually be used for you to detect pollutants in water. And now, ending with the last method, the question comes back again. Can we use paper chromatography to actually separate the different substances within the ink, that's left behind by the murderer? If so, why? If not, why not? Alright, so once you are done with the entire thinking questions, right now what I have for you is actually the results of all our analysis. I'm pretty sure that right now you have found that the method to use is actually to use paper chromatography to resolve and see whether which is the murderer that left behind the ink. Now, if I show you this entire example, this is actually what I call the chromatogram. Now, a chromatogram is the final state of a chromatography paper. Okay, so a chromatogram is actually what we call the final state of a chromatography paper. What is a chromatography paper? Basically, it refers to this paper that you were looking at the start. So basically, at the very start, right, what we have over here is called the filter paper, right? And our name for this is actually also called the chromatography paper. And once the separation has finished, that the product that we end up with, as shown over here, is what we call the chromatogram. Okay, so likewise over here in this question, I'm trying to show you what happens after I use paper chromatography to separate out all the ink spots as per what I see. And this entire piece of thing is what I call the chromatogram. So based on the analysis of the colored substances in the ink that's left behind, who do you think is the criminal? But more importantly, you need to explain why do you think that particular person is the criminal. So basically with that, we have come to the end of the methods of separation. The next part of the lesson actually touches on how we can use the different methods to allow Singapore to actually obtain pure water for its own survival, so that all of us here in Singapore can actually have access to clean and drinkable water.